All right, guys, in this lesson, we're going to talk about applying the counting principle and then permutations. So let's start with the fundamental counting principle. So let's look at an example. So for example, we have a sporting goods store that offers 3 types of snowboards and 2 types of boots. How many choices does the store offer for snowboarding equipment? Now, at this point, we've looked at kind of 2 ways of figuring this out. We can look at a tree diagram. So what we would do is we'd say, okay, we'd start with our 3 types of snowboards, all mountain, freestyle, and carving. All mountain would branch off to go to soft and hybrid for boots. Freestyle would have soft or hybrid, and carving would have soft and hybrid. So you would see that we would get 1, 2, 3, 4, 5, 6 possibilities. Another way to do this is with a table. So you've probably done this with a table as well. So all mountain, freestyle, and carving, my types of snowboards are on the left. My type of boots are on the top. You could actually flip-flop these, but either way you can see that we get the same 6 possibilities. So how many choices are there? There are 6 choices. Now this isn't terrible when you only have 3 and 2 to work with, but what if we had 500 choices of snowboards and 58 choices of boots? You're not going to want to make a tree diagram or a table. So instead we have what's called the fundamental counting principle, and it's pretty much common sense. It simply says that if we take the options for the first choice, so we have 3 snowboards, and we take the options for the boots, so we have 2 boots, and we multiply them together, we will get the number of choices. So notice I got the same answer, 6. Okay, and you can actually see this really well in the table because this looks very much like a multiplication table. Okay, you'd multiply all mountain times soft and so on and have 6 choices. Okay, so that's simply what the fundamental counting principle says. Just multiply them together and you'll get the same answer. So this works for 2 events. If you have 2 events, you simply multiply them together, but it works for as many events as you have. So let's say you had 3 events, it would be m times n times p. If you had 4 events, you just keep multiplying them together, okay? So let's look at an example. You are framing a picture. The frames are available in 12 different styles. Each style is available in 55 different colors. So we got 12 styles. So these are the number of styles. We have 55 colors, and that's for the frame. And then we also have, we want a blue mat and has 11 different shades of blue. So 11 is the number of blue mats. We're simply going to take these 3 numbers and multiply them together. This would be quite frustrating to make a diagram of. So if we multiply these 3 numbers together, we should get 7,260. But you might want to check me. Sometimes my math is a little off, you know that. So how many options? 7,260 different options. So we have quite a few different options to work with. Okay, so now let's look at number 2. The standard configuration for a Texas license plate is 1 letter followed by 2 digits followed by 3 letters. Okay, so that's a lot of information. Let's write that down. So we have 1 letter, so this is a letter, followed by 2 digits, followed by 3 letters. Okay, so I'm just kind of writing myself a little roadmap to what it looks like. So basically it has 6 different characters. How many different license plates are possible if letters and digits can be repeated? Okay, so let's think this through. We have how many letters in the alphabet? Hopefully you said 26. There are 26 letters in the alphabet in America here. So 26 choices for the first letter. Now, how many digits are there? Well, hopefully you said 10 because you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So there are 9 digits. Okay, so 9 digits. Now, I'm sorry, I don't know why I said 9. There are 10 digits. Got so carried away. 10 digits. Let's try that again. Now, because they can be repeated, so let's say I put the number 2 here. Well, I could have the number 2 here again. I could have 22. So that means I still have 10 digits to choose from for this particular license plate. So this is because they can be repeated. If they couldn't be repeated, I would have to put 9 there. So like if this was a 5, then this one couldn't be a 5 if it said no repetition. But there is repetition, so 10 times 10. Now, how many letters? Again, so again, because we can repeat the letters, so we could have A, 5, 5, A. We could have that. So there's 26 letters, 26 letters, and 26 letters. And again, this is because we are allowed to repeat the letters. So now we're going to take and multiply all these lovely numbers together. So when you multiply these 6 numbers, I believe you should get 45,697,600 license plates. So that's quite a lot. Okay, so that allows for all the different possibilities. Now, on part B it says, well, how many different license plates are possible if letters and digits cannot be repeated? Okay, so they've thrown kind of a kink in this now. It's a little bit different problem because now we can't repeat. So it's important that they tell us this. So again, we have those same 6 letters, right? So 1, 2, 3, 4, 5, 6. You don't have to draw the lines. I like to draw them to keep track of what I'm working with. So the first one is a letter. So I still have 26 choices for that first one. So let's say, I don't know, it was an A. Okay, that means I can't use A again. So that means this other letter over here, then now there's only 25 choices because I've already used a letter for 26. And now there's only 24 choices for this letter. And now there's only 23 choices for this letter. So every time we have to take out that choice once we use it. Same thing with our digits. Now we still have 10 digits, but let's say we chose the number 5. We can't use 5 now. So now there's only 9 to choose from. So hopefully you can see that there's going to be less choices if we take out repetition. So again, if I multiply all of these things together, I should get 32,292,000 license plates. Okay, so still a very large sum, but not nearly as many if we can include the repetition. Okay, so that is the fundamental counting principle.